Okay, now that we have a better understanding of person time, in this problem we're going to calculate incidence rates. And again, this differs from cumulative incidence because our denominator is person time, which allows us to not make any assumptions about how long people were at risk during our observation period. We have a much more specific denominator. So let's go through and start by reading our question. As the lead investigator of the study of Temple students, you recognize that there has been significant loss to follow-up in your study sample. So basically, people are gone. They're transferring colleges, some dropped out, they've transferred, or some have just stopped responding to your survey. So there's a dynamic population here. People are moving, and you're not able to track them. By assuming a denominator, or by using a denominator that reflects your study sample at the beginning of the study and assumes you have complete data for everyone, you may obtain an incorrect estimate of risk. So by calculating cumulative incidence, we may actually be getting the wrong number. Since you've collected data over every semester for 4 years, you realize you can determine more accurately how much time students contributed to the study, so how much person time they were at risk, and when each health outcome occurred. So the idea here is that, unlike in our problem of cumulative incidence where we said, okay, we measured people at the beginning of college and we measured them at the end of the college, and our health outcome happened sometime during that period, what this is actually saying to you is that we survey people every semester. So with every semester, we knew within the, since the last survey, did that person get that health indicator? And if they did, they'd be counted as a case, they'd be counted as a new event, and their time at risk would stop because they wouldn't continue to be at risk, they would already have our outcome. Okay, so we again have a slightly different table. Each row, as with the others, is our health indicator, and here we have a few different numbers. So I'm going to start from the right side. So our rightmost column is the number of students who were new cases and events, and this is over the 4 years, but remember they could have sort of been flagged as a new case at any one of the per semester survey period. So it's not that they were identified necessarily at the end of the study, but during the course of the study they ended up reporting they had one of these health events. We can then move to our middle column here where we have the number of students at risk at the beginning of college. And this number is actually the same as our cumulative incidence measure because it's using the data from the first wave of data collection and saying how many of these students have the potential to get our health outcome moving forward. But here's some new information. Person time contributed. So this is actually person years. And it's saying that each one of these students, how much person years, how many years of observation did they contribute to the study? So a maximum amount of person years that someone never got sick, never dropped out, etc., they would contribute, each person would contribute 4 person years. All right, so for incidence rate, the information we're going to use are the number of new cases and the person time contributed. So let's go to our first problem. What is the incidence rate of unintended pregnancy over the 4 years? And our formula for incidence rate is number of new cases over total person time, in this case it's person years, at risk. So for unintended pregnancy, we know that 252 new cases of unintended pregnancy happened over the 4 years that we were observing these students. And we know among the 2,000 women who were at risk at the beginning, they contributed 5,000 person years over the 4 years. Again, this accounts for, if students were lost to follow-up and we could never, track them down again, if they transferred to a different school, or if they, reported an unintended pregnancy, or actually, honestly, probably a pregnancy during that time, and we said, okay, you're no longer at risk for an unintended pregnancy. Therefore, we're going to stop counting the time you're contributing. So we end up with, if we do this division, per person year, which we can then multiply to 504 per 10,000 person years. I'm just going to shorten that. And hopefully you'll see that, you can multiply that by 10,000 and then you end up with 504 per 10,000. We could keep multiplying out. We can say 5,040 per 100,000 person years. These are just multiples of 10. So perhaps an easier way for people to understand this is that there were 504 unintended pregnancies per 10,000 persons, or in this case women, per year. And your choice of how you report this, I think, is really based on comprehension. What is your audience going to understand? They're probably going to understand 504 every year of this study. There are 504 cases or events of unintended pregnancy per 10,000 persons. All right, so we can do the same thing with depression. We'll use our same formula. We can see that there were 300, where did my video go? Hold on, sorry. There were 310 new cases of depression during the observation period. Our 3,000 students who were at risk for depression, based on at the start of the study, contributed 9,000 person years. So we end up with 0.034, which we can express as there were 34 new cases of depression per 1,000 persons per year. So really, you can maybe see, incidence rate is getting at what is sort of the speed of the health events. How quickly are they coming? And, obviously, what are the rate at which they are coming? Which is why we need the time aspect to our denominator.